Hello, my name is Megan Litchfield. I am a student at the University of New England. I'm going to be going over some spectra to elucidate a structure. Here's my name. All right, and my group is AA. Okay, so here is our structures. Well, here's our spectra to get to our structures. Thankfully, we're already given our molecular formula, so that makes it a little bit easier. This is our IR spectra, this is our C13 spectra, and this is our HNMR. All right, first off, whenever I look at a IR, I like to go ahead and find my 3000. I draw an imaginary line up, and I look at what's staring at me. So this region right here is going to be your C to H region. That tells us if we have an sp3 CDH or if we have an sp2. So right here, it shows that we have an sp3 and we also have an sp2. There also is this little area right here that makes me think, oh, is this something? Is this a nitrogen or is this an amine? But I look up and I see that I have no nitrogen in my chemical formula. So I'm going to ignore this and see that it is noise or artifact. I also looked right here and I was like, oh, is that an aldehyde? But with how much hydrogens we have and for like everything else that's going on, I believe that that's just noise as well. Then I'm going to go in our 1700 area. This is a very strong signal. This is our C to double bond O carbonyl region. So we can go ahead and identify that. And then I'm looking right in this area. This is all of my C double bond C region. And this is making me think aromatic because there are so many different aromatic fingers, and especially with how, with our degree of saturation, unsaturation, we have to have an aromatic. So all of this is confirming my hypothesis. But then we come over here, just above the 1000 mark, I see another strong signal that doesn't look like the rest. This is my C bond O. All right, and now we're looking at our carbon 13 NMR. I do another imaginary line. I draw it at 100 because anything on this side of 100 is sp2, and then anything on this side of 100 is sp3. So right here we have our carbon bonded to another carbon, and then we have another carbon bond to another carbon. This region on the C13 is anything below 40 is going to be my carbon bonded to carbon or carbon bonded to hydrogen. They are about the same height and same intensity, but they also, one is a little bit more de-shielded than the other one, so we'll talk about that. There's nothing going on in here. Usually this is where I would find my carbon bonded to an electronegative or my carbon bonded to two electronegatives, but there is nothing there. All right, on the other side of my 100, so now we got our sp2 region, I've got these 4 strong signals here. These are our aromatics. This is the aromatic region because these are where you have your carbon double bonded carbon. Other thing I forgot to mention is I counted 8 signals here. That doesn't mean that there isn't 9 signals. There could be one hidden in one of these extra signals, especially with our aromatic. And then these 2 signals right here, this is our ester land. 160 to 180 makes me think of like carbon double bonded O, and then right next to it in the like the 150s range is going to be that leaflet of my ester, which is the carbon double bonded carbon to an O. So I like to call that ester land. All right, coming down here to our HNMR. I go ahead and draw an imaginary line at 5 as well, because 5 and up is all my exciting stuff. So on our HNMR, anything below 2 is going to be like my simple C to H region. 2 to 3 is my carbonyl region. So here I have two signals, and they both have 2 hydrogens on them, so CH2, CH2. And then I have, it looks like they are both triplets. It's hard to see, 1, 2, 3, 1, 2, 3. But it looks like they both have 2 hydrogen neighbors. One has a little bit more intensity than the other one, and I went ahead and assigned it after the fact that this one goes, this is the CH2 that's next to the benzene, and then this is the CH2 that's next to the carbonyl. On this side, we have all of this is our benzene ring. Our 6 to 8, this is all aromatic stuff. You have 4 signals here. Each one has 1 H, 1 hydrogen applied to them. I tried to go in and count each one of these the best I could, but they're all mushed together. The best I got was 2 triplets and 2 doublets. All right, and then we're going to come down here. So degrees of unsaturation. We have 9 carbons times 2 plus 2 minus 8 hydrogens divided by 2 equals 6. So that's where I got a lot of my hypothesis, not guessing, but just identifying my different waveforms here by initially doing my degrees of saturation, seeing that I have 6. 6 is a high number, so it means that I'm going to have at least 1 aromatic ring or 1 benzene ring, and then I have 2 more degrees of unsaturation after that. That makes me think I'm going to have 2 double bonds somewhere else, or I'm going to have a ring and a double bond. All right, going back over our tables now. So as I discussed, the IR, so 1740, another thing whenever I was working through this, I looked up is a high indicator for a cyclic ester, because that's an ester region, and especially with the degrees of unsaturation, that would fit what I'm wanting to do is if I had another ring. I had like my benzene and a ring. So I went ahead and wrote that down. And then my CH region, my CH2 region, how it was it wasn't a strong, deep signal. Like sometimes it's like, woo, it's a big one. But it was very small there. So that makes me think, again, that we have an aromatic ring because it's muted. Those double bonds aren't allowing it to like stretch and get us crazy. Also, a ring wouldn't allow the sp3 to stretch as much as well. All right, and then as I went over before, my ester land, these numbers right here, and then I started attaching how they were attached, like, oh, this one is going to be attached to my benzene because it's a stronger signal. This one's going to be attached to my aromatic or my carbonyl. So as I wrote in here, you can see my thoughts on that. So these ones right here, those are all your aromatics, but I also put in assuming that there might be an extra one hidden, and you'll see why I keep saying that. And then I put in my HNMR shifts and stuff, and then I put down the triplet, doublet, triplet, doublet, and my scratchings right here for that. And then this is what I got. It might not be right, but this is what I am hypothesizing is the molecule. I had to do a lot of explaining and like defending this molecule, but this is it. So we have our benzene ring, and then we have those two carbons. Here's the CH2 carbon, CH2 carbon. Those are these ones right here. So the 3 HNMR is going to be where I'm attached right here, and then this H2 is going to be where I'm attached to the carbonyl. And then these are our unique carbon hydrogens on my ring. But that is my molecule, and I hope it's right. I had fun doing it. And oh, actually, little thing. So this one right here, so we got one hydrogen here, one hydrogen here, one hydrogen here, one hydrogen here. So for these, this is all correct. There's nothing hidden in here because there's no hydrogens on these two carbons right here. But I still think that there is a signal hidden right here for the aromatic carbon because all of these are unique carbons. Anyways, I hope you enjoyed. Thank you much.